Hello friends, this video on polynomials part 9 is brought to you by examfear.com. No more fear from exam. Now we'll talk about the very important concept, that is remainder theorem. Let's take one scenarios. There are 5 cookies and you have to distribute these cookies among these 2 kids. So you'll give the first cookie to this kid in blue, then the second cookie you'll give to the kid in red or pink, third cookie will go again to the kid in blue, and fourth will go to the kid in red. The fifth cookie is left. You don't have choice, right? If you have to either split it, but if the requirement is that you can't split the cookie, then this is the remainder. Right? So in the simple maths, there are 5 cookies divided by 2 people. So if you do your maths, each person gets 2 cookies and 1 is the remainder. Okay, so here in this case 2 is divisor and this is dividend, this is quotient, and this is remainder. Okay, so if you see here, this dividend here, dividend is nothing but divisor into quotient plus remainder. And also note here that the remainder is always less than divisor. See, there were 2 kids. The remainder, if we had 3 cookies more, we could have actually divided. So remainder is always less than divisor, not with quotient. Let's take another number to divide to get more clarity. Okay, so in this case quotient is 2, this is remainder, this is divisor, and this 7 is dividend. Okay, in some case the remainder is 0. For example, you divide 8 with 4, there is 0 remainder. So in this case I say that 4 is a factor of 8. For example, 9 divided by 3. Right? So I can say that 3 is a factor of 9. Okay? So this is division of numbers. The question is, we are understanding the chapter of polynomials. So can I divide 2 polynomials? For example, this is x square minus 4. Can I divide with this polynomial? These 2 are different polynomials. So can I divide px with qx? That is the question. Let's see what we can do. Right? So in this slide we try to understand what is remainder. How do you divide 2 numbers, and some case you get remainder, some case you don't get remainders. If you don't get remainders, you say this is a factor of this. Right? Now we'll try to divide 2 different polynomials. So let's try to divide x4 minus 4x with x. This, if you see the first, let's suppose this is px and this is qx. So px, if you see there's x common, we can write px as x cube minus 4 and qx is x. So I can divide this and you get x cube minus 4. Or let's suppose y to the power 7 minus y to the power 6 plus 2 divided by y. This will be a little difficult, but if there is a y here, we can actually do this. So this becomes y to the power 6 minus y to the power 5 plus 2. So you can actually divide 2 polynomials. Okay. So let's try to divide 3x square plus x plus 1 by x. So if you divide, you get 3x square by x plus x by x plus 1 by x. 3x square by x is okay, that is 3x. X by x is also okay, 1. But 1 by x becomes 1 by x, that is x to the power minus 1. And that means this is not divisible. This part is not divisible. So what I can do is I can write as nothing but x into 3x plus 1 and let 1 be the remainder. Correct? So if you see, if we compare this equation with this equation, this is my dividend and here I have division, this is my divisor. This is quotient, this is dividend, and this is remainder. Thus I can say that x is not the factor of this whole polynomial 3x square plus x plus 1. But if I had 3x square plus x, then I could have said x is a factor because this becomes 3x square, 3x plus 1. Right? You can actually divide, there is no remainder. Okay, since there was a remainder in this case, I can say that x is not a factor of this. Okay, because if, as I explained you, if 9 divides 3, I can say that if the remainder is 0, I can say 3 is the factor of 9. But if you say 8 divide 3, you get 2 as remainder. I cannot say, I can say that 2 is not the factor of 8. Sorry, 3 is not the factor of 8, but 3 is the factor of 9. Same thing. If x is dividing the whole polynomial, then I can say that x is the factor of this polynomial. But if x is not dividing this polynomial, if you see, when you divide with x, you get 1 as remainder. I can say that x is not the factor of this polynomial. Please note, remember this rule, very critical rule. If, let's suppose if I have px and qx. So if qx divides px, there is no remainder. I say that qx is the factor of px. If you divide px by qx, there is a remainder. That means you can say that qx is not the factor of px. Okay. So let's divide these numbers. Px is equal to x plus 3x square minus 1 and gx is 1 plus x. So I have 1 plus x and this is 3x square plus x minus 1. Or let me write this as x plus 1 to be more specific. Right? I just typically write in the power of decreasing exponent, x to the power 1, x to the power 0, x to the power 2, x to the power 1, x to the power 0. Okay, so let's multiply with 3x. So it becomes 3x square plus 3x. This gets cancelled. X minus 3x is minus 2x and minus 1 we have from here. So you can multiply with minus 2. Minus 2 into x is minus 2x. Minus 2 into plus 1 is minus 2. This gets cancelled. Minus 2 minus minus 2 is minus 2. Sorry, minus 1 minus minus 2 is minus 1 plus 2, that is plus 1. There is a remainder. Since there is a remainder, I can say that gx is not the factor of px. Okay, but if you see here, this is the complicated method to find the remainder. You have to actually divide. So if the number is of a bigger number, for example, x to the power 8, x to the power 7, that kind of number, that kind of polynomial, it is all the more difficult to divide. So instead of doing the actual division and finding remainder, we'll use a shortcut. Shortcut to find remainder. So what I'm trying to say is, instead of using this long method, we'll use a shortcut, and that shortcut is called remainder theorem. See, let me explain remainder theorem for you. See, this px was what? 3x square plus x minus 1. And we wrote this as multiplication of these two numbers and 1, that is x plus 1 into 3x minus 2 whole thing plus remainder, that is 1. Okay, now if you see, this was known to me before dividing. I knew this. This was known to me before dividing, right? The 3x minus 2 was not known to me before dividing. This came actually when we divided. 1 was also not known to me before dividing. The only two things known to me was these two. If somehow I can make this as 0, this was known to me, you can make this as 0. 0 into this number will become 0. And what will I get as remainder? Right? So if x plus 1 is 0, then x is nothing but minus 1. So if I put minus 1, if I get p of minus 1 here, let's see what I get. 3 into minus 1 square plus x is minus 1 plus minus 1. Solve this, you get 3 minus 1 minus 1, that is plus 1. And that is the remainder. Okay, so this is the remainder when this px is divided by x plus 1. Pretty easy now. See, what we did was, first we did the actual division. It took so long for us. Then we figured out that this px was nothing but x plus 1 into 3x minus 2, the quotient we got, plus remainder. Somehow smartly we knew this number before actually dividing. If we can make this 0, whatever number comes here, that will become, when you multiply it becomes 0, and what you get is remainder. And x plus 1 is 0, that is x equal to minus 1. So if you find p of minus 1, you will get the remainder. So p of minus 1 is nothing but remainder when px is divided by x plus 1. Got it? Okay, so whatever we have learned till now, it says that if px and gx are two polynomial, where obviously px has a higher degree than gx. For example, x plus 1 I can't divide by x square plus 2. This is degree 1, this is degree 2. It's not possible. But x square plus 2 I can divide by x plus 1. Right? So if we have two polynomial px and gx here, where degree of px is higher than gx, that is fine. And obviously gx would not be equal to 0. If it is equal to 0, something by 0 is infinite. Then actually we can divide and we can write px as this number gx into some quotient plus some remainder. Okay, so where this remainder will be equal to 0 if there is no remainder, or this degree of rx, the remainder, will be less than the degree of gx. Okay, and we say that when px is divided by gx, it gives qx as quotient and rx as remainder, where the degree of rx is less than degree of gx. This is clear? This is a general statement of whatever we have learned. Okay, and if you talk about remainder theorem, so when you divide px by x plus k, the remainder is nothing but p of minus k. Remainder is nothing but p of minus k. Thank you. Visit our website examfear.com to watch more and more quality educational videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.